to be permanent. All right. Could you look at the screen? Does it look like everything's...
Yeah.
All right, we got the whole front. Okay, awesome. We have some people that couldn't make it today. Today will be fun. Okay, so I heard something that Dr. Keith said. I sat in one of his sections last week, and I wanted to make the same plea. Because this IS 404 class, well, what he said was specifically was, because he was doing new content, he asked for patience, that there could be some, a little bit of construction dust on the educational process and delivery. And I thought I should say the same thing. So similarly, we've been doing the same thing for 404 for probably like 10 years. And this year I'm doing stuff that's completely new. I've got a new book, I got a lot of new material, but I've read every page of the book and I've taught the material many times before, but I haven't created your new labs yet. I haven't created your quizzes that you're going to be doing on any given day yet. So if anything's like a little bit out of sorts, I just ask you to bear with me. I'm going to do my very best to get you your quizzes and everything uploaded and takeable as effectively and efficiently as I can, but it probably won't be perfect every time. So just asking for patience. We had some surveys that we did to ask about should we do SONA. So the answer to that is no, so we won't be doing that in here. Upon reflection, I changed the approach last semester with how I usually do things as it relates to quizzes. Usually I have quizzes due not within a week of the lecture, but before the lecture. And I found, particularly in this section, that some folks felt that they weren't keeping up on the material as well. And so I'm going to go back to my old way of doing things. So just know that as we get into the book itself, that all the quizzes are going to be due before we have a lecture in class on any given day. Now, they're not going to be hard. They're open book, but you're expected to have at least skimmed, if not read, all the material so that you can take those open note quizzes before class each time. All right, any questions on class stuff? Just general structure? Okay, I don't think I've got anything else I want to hit for now. So, and I've got, we got a couple guests today, so let me get one of them in here. This person looks an awful lot like somebody you know, but it's not. This is actually a cousin of Dr. Wells. He's a CIO of a company called Initech, and go ahead and start talking. Go ahead.
All right, so you've been hired as a new employee of Initech, and we're thrilled that you're part of our team. You know that we hired you as a developer because you wanted that fat developer cash. But we actually had an incident. So at our organization, we had a fraud occur. And I heard you know a little bit about fraud. I'm not going to commit it. So we had one of our employees, whose name was Larry. Larry misappropriated some assets.
I'm going to go get our consultants.
Oh yeah, go get Gary. So
down in the lobby.
So Larry, not to be confused with Gary, Larry misappropriated some assets, stole ultimately around $40,000 from our company, and so through that fraud had to be removed. And so I know you were planning on doing dev work. I know that that's your passion, but in the next short period of time, we'd like to assign you to do some system admin work. That's what Larry was doing before the fraud. You know, as a company, you were going to develop for some of our servers. We run a whole bunch of VMs, so we've got thousands of VMs that need to be managed. And I hear that you know a little teeny bit about Linux, at least what the name Linux means. So because I know you're not an expert yet, what we've decided to do is we've decided to bring in an outside consultant named Gary, and Gary's going to kind of help you get up to speed so that you can manage some of our Linux servers. Okay? Any questions so far? Now, if you increase your knowledge in this, then maybe we can give you a little raise, even though sysadmins typically make a little less than developers do. Okay? All right. So let me go get Gary. I don't know where Gary went. So Gary's a consultant. He's a Linux expert. He costs a lot of money to bring in. He's going to be kind of mentoring you and helping you get up to speed.
Gary's not quite here yet.
We'll get Gary going. Now my understanding is you do know how to connect to some Linux servers, is that right? A little bit? Okay, so you're going to need to do that as you learn from Gary and figure everything out. Okay. Yes?
So did this Prosper, his name Deegan, right? He,
No, Larry.
knows?
Larry.
Yeah.
Did he do what?
Do you have any notes or any idea of what he left with him?
So he did a lot of things. It was mostly just theft. We have a lot of things that are worth quite a bit of money, right? Something misappropriates meth. Oh, Gary, come on in.
I'm your consultant.
So this is Gary. Gary is an expert in Linux. He knows a lot about things. We're paying him a lot of money to get you up to speed. So I'll leave you with Gary.
Thank you so much, CIO dude. All right. I need one of you guys to come up here, and someone who can log into their Linux machine to their Raspberry Pi. I'd like someone to come up and plug in here for me today. Okay, come on up, Mitch. So, hopefully it doesn't show up negatively on my student reviews. As background material, technically my dad's like a biker guy with tattoos and Vietnam War vet. But in terms of working in the marketplace, one of the first places I worked at, there was a guy who was on drugs and a little bit edgy, and he like ripped off some of the equipment, and there was that. And then there was another time when Dr. Kettles was interviewing for a job as a system admin type guy, and the guy interviewing him says, you know, you just don't look like the kind of guy I typically hire. He's like, you're wearing a suit and a tie, and you look like a lawyer, and you talk like a lawyer, and usually the people in this role have like a ponytail and long hair and maybe some piercings, and you just, I trust you that you can do the role, but something just feels a little off about this. All right, so I'm just having a little bit of fun with this today. It's a way to walk through some of this material. Okay, who did not get a Pi set up today so that you could use a Linux operating system and log in? Okay, hopefully not too many. If you're in that boat, you can open up like PowerShell, command prompt, Linux, or on a Mac, the terminal window, and you can go into my home Pi right now. Open up a terminal and go to SSH Pi at is404.dynamic-dns.net. When it asks you for a password, IS rocks. All right. Thank you for representing everybody here today as the new hire. Do you care for a chair? You'll be up here for a while.
Sure.
Okay.
We'll take this chair.
Sounds good. Okay. And just to make sure that I hit all the points that I want to hit, I wrote out a little script of things that I wanted to talk about. Okay, so first, as a system admin, overall, we just do whatever we get asked to do. That's accurate, but relatively inspecific. There are things related to Linux systems, Unix systems, that we do all the time, and so I'm going to write down about 7 of those right now. So, if you're hired on as a junior systems administrator doing something with Linux, here's some of the things you got to be worried about. You are going to be in charge of preparing, installing operating systems, Linux being a key one. You're going to be involved with making sure that those installed systems have network connectivity, or in some cases, network restrictions. So, server's not much good if it can't talk to the outside world. Server's also not much good if it gets hacked. So there's that. Another thing that you're going to be involved in is managing file systems. So within Linux, create files, restrict access to files, etc. Another thing you have to worry about is, and we're going to go over most of these in a little bit greater depth, but creating users, or maybe even just managing users and groups, people that can perform operations within your operating system. Another thing you want to worry about is monitoring processes. So every application that you run, Apache web server, Nginx web server, Postgres database, everything can be considered as a process, and you want to watch and see how those are performing. You have software installation and patching. As things get out of date, there are security holes. Sometimes you want to remove things. This is your job. Now, this is not a small job. Well, it is a small job if you're just talking about running on your desktop computer. But when you start talking about 5 or 10 or 20,000 servers, this becomes a huge job. Another thing you want to do is you need to monitor the logs, so your system logs. Particularly for historical reasons, if you've been hacked, you want to know what's been going on in there, or if something went down, what caused the crash. So you need access to all of your logs. And then lastly, I'll put on here consulting. So as a Linux admin, you're going to be regularly approached by people like such as developers who have questions related to Unix or Linux and want to use it better. So do you have any questions about any of those categories? Want to know more about them before I get much farther? What they mean, all straightforward. Yes, sir.
What do you mean by monitoring logs? Like traffic or?
So logs will be created by, for example, a web server. Logs will be created by people logging into and using it. So depending on what your problem or concern is, you will at times go to the logs to investigate them for the items of interest.
Okay.
For a web server, it could be things like a problem that occurred, or it could just be things like, where's my traffic coming from? The logs will show you that, oh, hey, my traffic is coming from Europe versus Northwest California versus, Asia. So all kinds of interesting things you can do with your logs. Yes, sir.
So you said system administrator, and then you said Linux admin, maybe another term. Are those all synonymous, or just?
Yeah, I'm going to use them as relatively synonymous here. I mean, today we're really hyper-focused on being a Linux administrator, but if we go a little bit more broader, we could just say system administrator. Technically, there are other systems, Windows. If you manage a fleet of web servers, you might have a lot of Windows servers as well. So generally, if you're a system admin, it's assumed that you're going to be managing OSs and all those things related to OSs. Okay, so one of the first things I had on here was preparing and installing an OS as one of your jobs. Brought something a little bit old school here.
Unfortunately, I have way too many couches in here. So, all right, hold on. I may have to.
Okay, here it is. Okay, so historically, if I was going to install Linux or if I was going to install a Windows OS, I used to use disks like this. I'd put it in the CD-ROM. Usually when the computer's booting, I hit a certain key and I say boot from disk, and I can install from a disk. These days, so this is Windows XP right here. These days you can take a digital copy of this, usually called an ISO file, and use that as the basis for installing things. As I understand, you've used the noobs folder of information with an operating system on it to install Raspbian recently, a version of Debian Linux. That's correct?
Yeah, that's right, Gary.
Pardon?
That's right, Gary.
Right on. Okay, so you know a little something about installing operating systems on hardware, so we're good to go there. Another thing that you need to be concerned about as a Linux admin or system admin is interfacing with networks. I'm not going to do a whole lot with that today because you have a lot more to learn about networking in the future months ahead. But for now, just as a sneak peek, would you mind going up and opening up your terminal window? If you were running just a regular Windows machine, you would open up the command prompt and you could type ipconfig. But on here, let me turn the lights back down. Type in ifconfig. Okay, so having typed that, and then I think if you go into the edit menu, you can blow this up for everybody to see a little better. Or we want the font bigger. So it's like Shift plus or something like that. It's under the edit menu. Shift Control plus plus. Okay. Okay. All right, so I'm looking at the information there. On the left-hand side, I see what are 3 different network interfaces for this particular device. So depending on which computer you log into, it's going to have more or less network cards. If I took a traditional desktop PC and I put a whole bunch of network cards in there, then each one of those would show up in the list over on the left. So as I just glance at this appears to have 3 network interfaces or ways to connect to the outside world. One of them says Ethernet 0, and there's nothing too much interesting going on there. LO is the loopback address, and it says 127.0.0.1, that's localhost. That's not going to be too interesting for us right now. The third one, WLAN, as it relates to a Raspberry Pi, represents your wireless interface. And I see that the internet address there is 192.168.1.167. That's its IP address within a private network somewhere. Is this at your home?
Yeah.
Okay. So anything that begins with 192.168 is in the private address space, and you'll learn a whole bunch more about that in the future. All right, with that, let's go on to the next topic. So let's talk about users and groups. Typically, when you install a Linux system, you are logging in as the root user. Right now, the Pi user is a quasi-root user. What is the problem with installing a root user and then giving out that username and password to everybody in an organization? Let's imagine that everybody in here is part of your organization. What would be the problem with giving everybody the same username and password, Whitney?
So if there are instances of like fraud or other things that's like not computer, you can't track it to who actually did it.
Yeah, that's a perfect answer. Was it Whitney? Was it Mitchell? Like, who was it that did something bad on the system? You don't really have a way of knowing. Yeah.
Everybody would have admin rights.
Everybody has admin rights, and what could a noob do with admin rights?
Accidentally delete system 32.
They can do all kinds of things, yeah. This isn't the same kind of issue, but in production, people will do things like they'll do a delete command on SQL databases, and they'll like wipe out an entire table in production. Oops. Yeah, so you don't want people making mistakes in production. Okay, so those were some fantastic answers. So because of that, we want to create, as soon as we get onto a system, we want to start creating users and then locking down what they can and can't do. And furthermore, we want to organize users into groups. What would be the benefit of having groups? Yeah?
You can edit all the rights for a specific group of people at once.
Yeah. So what might be some groups of users as it relates to an operating system? Things that one group could do that you wouldn't want another to do. All right, I'll
Basic employees, programmers.
Okay, you might have some programmers. You might have some security professionals, just end users that want to just read some files. Might have some auditors from an outside firm. So depending on who people are, you might want to assign them permissions and then isolate them from doing other things. Okay, and it's just a proof. We're not going to do this right now, but as a potential activity we could do is if all of your IP addresses were publicly available, we could have you just log into everybody else's machines using things like Pi and Raspberry as the default username and password, and realize what a bad idea this was. But we'll skip that today. We'll do some other things. Let us go ahead and look at the user system on this fresh out-of-the-box system. So type the word cat, C-A-T. Everybody can do this.
One more time.
Pardon?
Oh, sorry.
Cat, and then, so everybody can follow along with all the commands we're going to do. /, etc, I'll say etc in the future, / PASSWD. Okay, having done that, what we're seeing is right out of the box, all of the users that are installed on this particular operating system. No, you can stay there. Along the left-hand side is the user names. Following that, a couple spaces out, is the number for the user and the number for the group that they're in. So let's look at that first line up there. It says root x00 root. So some of the things that I'm seeing there are, this is identified as user number 0, who's in group number 0. That group is named root also. There's a lot of redundancy in that aspect. Oftentimes you'll see that the user on the right is matched by the group name that they're a part of 5 spaces down. All the different settings there are separated by colons. Then you get to see what their what their directory is. So if you log into a computer as them, they can optionally be dumped off into a particular folder every single time. And then the last thing I think is the shell that's going to be involved, or some of the commands that are going to be enabled for them after they have logged in. Okay, so these are their usernames. Now let's see if we can see their passwords. So type in CAT again, cat, /Etsy/shadow. And it's not going to work. But, okay, what does it say there?
Permission denied.
Permission denied. Okay, so there's a lot of operations that you can't do as a regular user unless you elevate your privileges to the super user. So we're going to use the command sudo, or actually better pronounced sudo, which stands for super user do. So do an operation as if you were a super user. Now do the same thing again, cat Etsy shadow. And by the way, this right here says sudo, and then right there it says highway to shell. So we're in a shell window right now. So, all right. So what we see here is that for one particular user Pi, there is a hashed password. So technically, your passwords are not saved in plain text on these systems. When you enter in your username and password, it runs a little function to hash that password and then see if that hash password that you just entered in matches with the one that's on file. Hopefully that makes sense intuitively, like why that would be good security. If not, your security training farther on will teach you more about that. So I think probably back in the old days, it was probably just sitting there in plain text in a directory what your username and passwords were. But now we're a little bit better and smarter about things. Yeah.
I'm actually trying to log into your Pi, but it's not letting me type the password like at all. I don't know if I'm doing it correctly or.
You just type it, it won't show up, but you just have to type it.
Like you said, okay. Yeah, now. What was it? ISR?
Yeah.
ISR is all capital.
Yeah, so just as a proof of concept, would you mind just typing in those commands right now? So SSH pi at IS4, or just no E. IS404. Dot. -DNS.net. Now hit return. Oops. No, yeah, sorry. Yeah, now after that you hit return. Okay, it asks for so say yes. Yes. The whole world yes. The whole word yes. Okay, and now you type in ISROS.
Yeah, I got it.
Okay, now you're in.
Is that normal? Like it usually won't show up? Like.
Yeah, it's a good way to do things. So.
Is that exclamation point?
Yeah, it has an exclamation point. Okay, so technically he's gone from one Pi to another Pi. If you're a hacker, this is a great way to do things. If you want to launch an attack, you just go log into somebody else's computer, do all your commands from there, and then it looks like it's coming from somebody's computer. It's Adobe as opposed to your house. Or you just log into somewhere in China and then go over to Italy. Like you just compromise a whole bunch of computers, hop, and then launch for from wherever, and then hopefully then nobody ever finds you. Okay, awesome. So go ahead and just hit exit, and he'll jump off of mine, and now he'll be back on his. Okay, so yeah, question where? Yeah.
So, the reason why you can do that is just because Raspberry Pi to Pi is Linux and Linux.
It doesn't really matter so much as long as the SSH program is running on a computer. So you could SSH from Windows to any Linux machine, and then like that.
Can you SSH into a Windows machine, or does that not make sense?
You probably historically you could not. You should be able to do something comparable now. So it used to be that we would administer. Well, we've always administered Unix machines from the command line like this. There's so much we can do, and computers didn't originally have GUIs. But with Windows, I think people got really used to just using GUIs. But now we have PowerShell. So there's a lot of things that you could do on a Windows machine, and so you use PowerShell to run scripts that are equivalent to what we're doing here. So that's not a perfect answer, but I know you could administer them with PowerShell. You probably could log in some way. Yeah.
So, sudo's super user, what was the cat?
What does the word cat do? Cat is just a command that shows the content of a file. So if you had some code there, you wrote helloworld.py, py, you just do cat, that, and it'll show you the text of it. So rather than opening it up formally, you're just saying get a screen dump of the text that's in that folder, or that file. So. And for all of the commands that we do today, afterwards, I'm going to provide this little cheat sheet. And so it's in order. So the first thing is ifconfig. The second one is cat. So I'll open that to you later. And I might even just do a faster video of all of this. So we'll do this whole class in like 10 minutes. But in the meantime, we'll do this the fun way. Okay. Right now, I'd like you to add a user to this. So type in the word. Do you use Linux all the time? You already know.
I use Linux a bit, but
Okay.
I also have a cheat sheet right there.
Oh, okay.
So I kind of know what to do.
All right. So let's do user add and then put anything you want. Dave, Bob, Larry, Gary. You can even put usernames on mine if you're logged into it. It's fine. So user add and a name and hit return. Oh, shut down. So he's already guessing what the problem is, and he's right. So, oops, we got to do user add.
Oh.
Yep, darn. So this is a command that we can't run without elevated privileges. So user add Mitchell. He hits return, and we don't see any errors. That seems good, but common sense. Does it seem like there's anything missing? A password. We haven't entered in a password. So type in sudo passwd. Okay, so now we're going to add, and so go to the end of the line, and we mentioned the user that we're going to add a password for. Hit return. Now it's going to ask for the password. So make up any password that you want. Awesome. Okay. Yes, sir.
Can we move that window a little bit? It just stays like right.
Oh. Yeah, I wonder, can we
just
like,
move the window?
yeah, can we move the window up a little bit so it's above your head overall? Because right now it's maximized. Could we like resize it and make it so it's still got great font, but it's just higher up in the air?
Thank you.
That's awesome, thank you. Okay. If I wanted to find out if this user got successfully added to the system based on something that we recently did, how might I investigate that? Let's go back about two steps.
Password.
Yeah, cat etc password. So, so not the shadow one, although that one probably shows you something too. All right, go ahead, check that out. There we go. What do we see in the bottom line? Oops.
There it is.
This user has been created. Awesome. Okay. I'm going to pose a question, but I'm not going to give you the answer. I'm going to pose a question, but I'm not going to give you the answer. The answer is not necessarily important. the awareness of the problem is, if you're administering 5,000 servers and you need to be on top of all of the users on every single one of them, knowing that it has that many users out of the box, and then people could be adding them at any time, how would you keep on top of that for 5,000 different devices? Okay, no answer, just recognize it as a concern. Okay, next topic. Would you open a web browser? You could even use the little web browser up in the almost upper left there. Yep.
Can I ask a question?
Yes, please do.
I have two users with the same password with caching the same.
Like, what happens if you have 2 users with the same username and password?
Not the different names, same password, who's that hash, who's the same.
Well, I'm not sure how they implement it, but it should. It's possible that it could be. But the fact that you thought about that tells me that other people would have thought about that, and so they probably, it's probably different. So sometimes when we manipulate our hashing algorithms, we include something that we may call a salt or something like that. Anyway, try it, and you tell us.
I already did.
And did they come out different?
I'm hoping that they're the same passwords.
Does it look the same? Okay. So they thought they must add something else, like it must have something to do with your username that they use as an additional factor for creating a password, would be my guess. Okay, but you can ask Dr. Wells. Yeah, because that's his ball game. Okay, in the search bar there, type in the following. Now we're moving on to the next topic. After users and groups, we want to talk about file systems. So type in, well, it's going to be right here. Linux File Systems Basics Tutorials point. All those words. Linux File Systems Basics Tutorials point. If you get close, it'll get you there. Okay, so you see the tutorials point URL that's there. Go ahead and click on that. All right, there's a table here related to the directory structure or folders within your operating system. So scroll down a little bit, please. Oh, yeah, okay, yeah, right where it starts with 1, and then we'll get as many of those on the screen as we can, like 1 through 8. Okay, great. This will be our reference sheet. Let's go back to your window for a second and type in CD, which means change directory, and then do /. Okay, and hit return. Over here, this little squiggly line is tilde. It means that you're in your home directory. Now it's showing that you are in the root directory of the entire operating system in terms of the folder structure. If you don't mind, please type ls. Okay, ls is something to show the contents of that folder. Everything that's in blue is another folder there. So every single Unix system that gets installed has a root path or folder, and it's got a lot of standardized other folders in there. You should know what these things are. This is really this / is really the equivalent of your C drive. So if you're on Windows, you may have noticed at times that, oh, hey, I've got a program files folder, I've got a users folder, like maybe a temp folder. There's a standardized structure to Linux systems like this. So let's just create a little bit of awareness about what's in there. So let's go over to this document. Just back to the web page again. All right, so the second one says bin. This is where executable files are located, available to all users. Next one, device drivers. etc is one of the things that includes our configuration files. As we move on down, home oftentimes contains the home directories for new users that we add. And somewhere in this list will be var. Var is usually where we find log files and where we store those. All right, let's go over to, now let's revisit again the definition for bin. What does bin hold? Executables available to pretty much all users on the system. So let's go over here to our terminal window. Let's look at the contents of that. Type, in this case, actually get rid of the CD and just type ls space / bin. Yep. Okay. here are a list of commands that can be run. Do any of those look familiar to you yet? Have you seen any of those before?
Make directory, feature.
Okay, we haven't done make dir yet, we will. But it's familiar to you. Is there any commands that we've run already today that are here? Okay, cat, ls is there, yeah. Great, so this is where we get access to a lot of different commands. So when we type things in, your shell is automatically aware that any of these commands could be used. A question I got recently was, what do the different colors mean? Historically, I'm not 100% sure, I'll have to double check, but historically something for you to be aware of. Sometimes something is just an executable command, and sometimes something is a symlink, which is the same thing as a shortcut. So as people iterate and get better with Linux and its structure and stuff, sometimes they want to leave something in its original directory by design, but they want to include a reference to it somewhere else. So some of those things are going to be literally commands that are sitting there, and some of them are just links to those commands, but it works like a shortcut. All of those are commands that run. Under the hood, though, how they operate is a little bit different. All right, any questions so far? Okay. Let us go to type in cd/etc. You recall what I said is in there? Highlighted? Configuration files. That's one thing I'm concerned about right now. So type ls, please. Hit return. One of the configuration files that, or areas of configuration that you can be concerned with for one of these operating systems is the startup script area. So over the years, they kind of changed how this works with Linux systems, but I think it's backward compatible. So one thing you'll see is further up, you'll see like rc.local. It's in, oh, okay, yeah. We see RC and then a whole bunch of these, and then right here there's a file that says rc.local. There's another folder around somewhere as well called init.d. All these things that are prefixed by init.d and rc, these relate to startup scripts that happen when you boot up the computer. Would you mind just typing in cat rc.local? Oops.
I can't spell.
Okay. At the top of this program, it says bin sh. It's basically telling us that this is going to be a bash script. We're in essence running a programming language. So does this little part down here look like programming? Yeah, because there's an if statement there. So just so you know, systems like Windows with PowerShell and Linux, Unix with Bash have their own programming languages. They're kind of dumbed down. They don't do as much. There's a lot of text manipulation in them, and there's some if statements, but they don't really need quite the scope of other languages. They just really need to be able to read files and run some basic programs that are existing on the operating system itself. So some people, their whole life, or a significant portion of their life, is around building up these scripts. So if you want to add something else to your tool belt, this is something you can do. I know some of the interns from the iOS program here, that's what they'll unexpectedly spend their summer doing. Like they'll be using bash scripts and things like that to build continuous deployment pipelines for the programming environment that they're working in and stuff. So this could be your world. Who knows? Oh, hey, I forgot this one last time. Type in the command df. Okay, this command stands for disk free. And the way that it's written right now is not easily consumable by the human eyes. So type it again, this time do df, and do -h. Okay, so what we're seeing here are, in essence, the folders or the partitions that are being seen by the operating system. And we can see how big they are and how much space is available. Why do you think it's important as an admin to know how much space is available on a given device? You got 5,000, okay, go ahead. Okay. Oh, okay, I heard upgrade, backup. Yes, all those concepts are involved, yeah.
Yeah, each database is distributed across multiple computers.
Okay, or let's just go start with, you've got a huge database. People keep on using your systems. Your storage is filling up. You've got 5,000 servers. Do you need to keep on top of that? Yes, like historically, in my background, when things filled up, typically suddenly the whole operating system was corrupted and it might not start again. It was horrific if you filled up your entire hard drive. You might not recover. If you don't have a backup, you got a problem. Like you might not be able to bring your system back up when it crashes, when that happens. So it is important to be able to run commands like this and monitor them. Okay, let's go back to your home directory again. Type CD, and then just CD all by itself, and hit return. Now you get that little tilde squiggly line there. Type in ls. All right, so what we see here happen to be a bunch of folders. This is your personal directory. Type in pwd. So that's another way of seeing like where am I at right now. So you can see you're in home pi. Okay, ls shows you the contents of your folder, but try this one out. ls space -a. Okay, what's different? Go ahead.
Some hidden files that are not shown.
That's exactly right. On Windows machines, just as well as Unix machines, you can have hidden files and hidden folders. So whenever it begins with a dot, it hides it by default. There's just some stuff that you don't use most of the time, and so it's just kind of nice to hide it. It's not that you can't ever see it. It's just that 9 times out of 10 or even more, you're not going to be manipulating those. So let's just kind of hide them until you need them. All right, let's break into another category of information. Type in ls-l. Okay. This is kind of the long view about our files, and this deserves some explanation. Actually, let's create just so that we have more to talk about. We're going to create a file with another command. So type the word touch, and then space hello.txt. Okay, you can hit the up arrow to see a previous command. Hit it again. Okay, well, let's go back to ls-l and hit return. Okay, so I want to talk about what we're seeing here. We see a list of the folders as well as the files that are contained in that directory. We see when it was created, how big it is. Over here we see who is the user on the system that created it, or who owns it rather, and what is the group that is associated, what is the group that owns that folder as well, or that file. Okay, going over to the left a little farther here, you see a sequence of 10 characters. The first character, it will say D if it's a directory, meaning it's a folder, or it will be a minus if it is just a regular text file or a program like hello world.py. It can be other things as well. I talked about shortcuts, so if it's a shortcut, it'll get some other symbol up there at the front. Okay, now of interest here, we then have a series of 9 characters that they repeat. So read, write, this actually stands for read, write, execute, read, no permissions, execute, read, no permissions, execute. The way this goes in order is the first 3 characters are the permissions that are assigned to the owner of the folder or the file. The next 3 characters are the permissions associated with members of the group. And then the last thing on here are permissions that are assigned to users that have logged into the system but aren't either the user or the group associated with what you're looking at. So, for example, you just created a user on there. Let's just say the user he created had been Bob. Bob really is not by default in the Pi group and he's not the user pi, so he would be associated with the last 3 characters there. Okay, so let's test out how this works. Let's create a directory in our home folder, call it makedir, MKDIR space, and we'll call our folder secret. All right, we'll hit return. Okay, now type ls and then -l so we can see the attributes of this. Okay, here is our secret folder. We can see the default permissions that got associated with it. So the user pi can do anything in there. Can people that are just general people that are not pi, that are members of the group pi, what can they do or not do within that directory at this point?
Read and execute.
They can read and execute, but they cannot write. Okay, so and execute is historically when we do our bash scripts and Perl scripts and things like that, these programs that run on there, those become executable. Those are the things that we're talking about when we talk about executing a file. So usually we create programs. Is that program executable or not? Okay, so let's change the permissions related to that folder right now. So type chmod space 770 space secret and hit return. And then we'll do ls-l. Okay, so what is the significance of the, what is the explanation or interpretation of the permissions related to secret right now?
That the
Jeff?
group, we changed it so that the people who are part of group pi can now write
They can,
files.
okay?
They can do everything that the owner can.
That is absolutely correct.
And those who aren't the user or the group can't,
If they're not in the pi group, and if they're not the user pi, they can do what?
they can't do anything.
They can't do anything. All right, so let us test that right now. As the user pi, let's just jump in there and say, yeah, just type ls. Actually, instead of, yeah, we'll just type ls secret. That'll show us the contents of it, which is technically nothing right now. But go ahead and hit return. Okay, it is empty, so it's not going to show us anything. Should we be able to do this if we're a user that like he described? They're not in the pi group and they're not pi. No, let's test that. So you created a user before, a new user. So type su, so switch user, space, and then the name of the user that you created before, and then hit return. It will ask you for the password. Okay, he is now, instead of pi on this machine, this host name, he is now Mitchell on this computer, and he is still in the home pi directories. Yeah, go ahead and hit ls. Okay, so he typed ls. He can still see the folder there. He knows that it exists, but can we see what's inside of it? So type ls secret. Denied. Okay, well, can you get into it? So type cd. Can you cd into secret? Denied. Okay, so we have some control over our infrastructure. So for those that are control freaks, this should please you. Okay, so let's go ahead and exit out of this. So so what he was about to do is an interesting thing. I saw it last class. Technically, you can switch user over into this new account, and then switch user again, enter in the password, and go back into the Pi account. And you can keep on doing that, but you're technically a user logged in as another user logged in as another user, which is weird. It works, but the smarter thing to do is just back down one and say exit. So he said exit one time, now he's back to the Pi user, based on what you can see there. All right, so, the question that you're going to ask that you haven't asked yet is like, where'd you come up with this number 770 from? Okay, so in terms of read, write, execute, read is represented by the number 4, write is represented by the number 2, and execute is represented by the number 1. So, if I had a file called hello.txt, and I did chmod 111 hello.txt, what have I done? Yeah?
So the user group and the third users, they know all execute the file.
Everybody can execute the file, yes. How about what if, since I've got this great shirt on, what if I do, what if I chmod 666?
You can all read.
Read and write, but not execute.
That's right, we can read and write but not execute. Okay, so based on combinations of numbers and how you add them up, you can change the permissioning related to a file or a folder. There's also other ways you can do it. You can do like chmod plus X and stuff like that. And if you want to learn that way, you can do that as well. I think this is kind of straightforward and easy, so I'll put it into our study guide for the first exam and have us do something with that. Like maybe I'll tell you to write the command to do something, or I'll ask you to interpret it. So that sounds like fair game. Yeah.
So I messed up and put like 7700, and it like, yeah, it was super weird. But it changed it, and I don't understand like how or like what, but it had like DRWS, and then it had S, and then it had T, like a giant S.
Huh.
Do you know what?
Off the top of my head, I don't know what you did, but I'm super.
I just changed it, so it's fine.
Okay. All right. Yeah. Awesome. All right. As it relates to files. Okay. Let me just bring this back down again. I'll take your question in just a second. It's coming. Yeah. So you're trying to get a context for, like, what is this thing with the users? Yeah, so I mean, start off with when people started doing this, 30, 40, 50 years ago. You're in a university setting. Everybody in the computer science department's like, we have a computer? Oh, that's so cool. Can I have a username and password for it? And then everybody kind of jumps in there, and you can run your little astronomy programs or doing whatever. So as a shared system, that would have been kind of the original idea. A bunch of users in computer science departments or something would all log in and do stuff. Now we think of it a little bit differently, perhaps. You notice that there were a lot of pre-existing users on the system, and one of the reasons for that is that in addition to just regular people, whenever we install a program on a computer, we typically create a user for them. So a program runs as if it were a user. So when we install, for example, the Apache web server, we give it a user and a group. So everything it does can be controlled. We can say there's a certain folder on that computer that Apache can write to and nothing else can. So you can carry that example to lots of other different programs. Say, okay, this program can do certain things and not other things by virtue of the fact that it's associated with a given user. Yeah.
So like, for example, when you download a program from the internet, it's like, this wants to make changes on your device. Is that like kind of like giving it permission? Kind of like the same type of
Well, when I think of like the Windows world, when we say, hey, this thing wants to make changes to your device, at that point, you don't really, in that sense, you don't really know what it's doing. Linux, it could be a little bit different, but on Windows, yeah, when you run that executable, it could be doing anything. It could potentially access anything, anywhere on your computer. Yeah.
So this might be a little off topic, but before we did the exit command, I did the sudo on the secret file,
Uh-huh.
and it pulled up a bunch of stuff, telling me to respect the privacy of others, and then the password.
Okay, yeah, so